Hi everyone, welcome back to my channel. So few questions of chapter 1, that is numericals, are remaining. So let me complete that in this session. Okay. So till 1.17 we have done in the previous session. Today we will start with 1.18, exercise 1.18. So the question is like this: a point charge plus 10 microcoulomb is a distance 5 cm directly above the center of a square of side 10 cm. So you have 5 microcoulomb and side is 10 cm, which is given in your textbook. The figure is given. What is the magnitude of electric flux through the square? Hint is given, that is, think of the square as one face of a cube with edge 10 centimeters. So you have to consider the square as a cube wherein you place 10 microcoulomb at the center of the cube. So which is at a distance of, this is 10 centimeter is side of each square distance. So 5 centimeter above the center you are placing 10 microcoulomb. So what you have to consider is magnitude of the electric flux. That is what you have to consider. So as given in the hint, you have to now consider the square as a cube whose side is 10 centimeter. Okay. So from here, this side is 10 centimeter. From here, at the distance of 5 centimeter, so say that this is 5 centimeter, you are placing 10 microcoulomb charge. What are you asked to find out? You are asked to find out the flux. Find out the magnitude of the electric flux. Okay. So symmetry of 6 faces of the cube tells us that flux is same throughout all the surfaces. So 6 faces when you consider as the cube, so it is same throughout the surfaces. So the total electric flux phi E is equal to 6 into flux through each surface. So that should be equal to Q by epsilon naught. So this is Gauss law. So phi E should be equal to Q by epsilon naught, but since we are considering the cube which has 6 faces, so it is 6 phi S. Phi S is nothing but flux through each surface. That should be equal to Q by epsilon naught. So directly you can find out phi S. So phi S should be equal to Q by 6 into epsilon naught. Substitute each value. So for epsilon naught, what you can write? So 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9. So epsilon naught or 1 by epsilon naught will be equal to what? 1 by epsilon naught will be equal to 4 pi into 9 into 10 to the power 9. This please remember so that your calculation becomes easier. Otherwise you have to substitute epsilon naught as 8.854. into 10 to the power 12 and all. So it is 4 pi into 9 into 10 to the power 9. So substitute this value. So it is 1 by 6 into 4 pi into 9 into 10 to the power 9 into Q is what? 10 microcoulomb plus 10 microcoulomb. Micro is 10 raised to minus 6. So you get phi S. Substitute the values, simplify it further, and the answer comes out to be 1.88 into 10 to the power 5 Newton meter square per coulomb. Newton meter square per coulomb. So this is the answer. Okay. So consider the square as a cube which is given in the hint. So even in the exam that hint will be given. Wherever required, hint will be given. So use that hint and then use the concept. Okay, phi e, and cube has 6 faces, so 6 into phi s. Phi s is nothing but flux through each phase. So substitute all the values and please keep this concept in mind. So 1 by 4 pi epsilon naught as 9 into 10 to the power 9. 1 by epsilon naught as 4 pi into 9 into 10 to the power 9. So substitute the value and simplify it further, and always remember, write the units clearly. Okay, which is very important. Even though the answer is correct, if you don't write the unit, you will surely lose your mark, half mark at least. So please see that you write it neatly and clearly. Okay. So next question is 1.19. What is given? A point charge of 2 microcoulomb is at the center of the cubic Gaussian surface 9 cm on edge. What is the net electric flux through the surface? So you have cubic Gaussian surface, and note that this 9 cm is of no use, because when you consider and you have Gaussian surface, what is important there? Cube and epsilon naught. So the side will not come into picture, it is just given to confuse you, that's it. Okay. So read the question carefully and clearly, understand the situation, understand what concept has to be used. Okay. So point charge of 2 microcoulomb, 2 microcoulomb is given, Q as 2 microcoulomb, and you have to calculate the net electric flux. Flux has to be calculated. So phi, you have phi is equal to Q by epsilon naught. Substitute that. 2 into micro is 10 to the power minus 6, and epsilon naught. What will you substitute for epsilon naught? Again 1 by 4 pi epsilon naught is 9 into 10 to the power 9. So 1 by epsilon naught will be 4 pi into 9 into 10 to the power 9. So substitute the corresponding values, you get 2.26 into 10 to the power 5. Newton meter square per coulomb. Okay, this is a simple exercise. I hope this is clear to you all. Okay, phi is equal to Q by epsilon naught. Or else you have to substitute this value 8.85 into 10 to the power minus 12. That value you have to substitute and then simplify it further. Okay. Fine. Let's move on to the next one. It's 1.20. Anyways, additional exercises are not there. So you have 4 more questions remaining. 1.20. A point charge causes an electric flux of -1, see that minus is important, -1 into 10 to the power 3 Newton meter square per coulomb. Okay, so -1 into 10 to the power 3 Newton meter square per coulomb. This is flux. To pass through a spherical Gaussian surface of 10 centimeter radius centered on the charge. So you have to calculate 2 points here. First one is, if the radius of the Gaussian surface were doubled, how much flux would pass through the surface? Again, think the concept. Gaussian surface, Gauss law. Distance will not come into picture, so you have the same formula and flux. If the radius were doubled, how much flux would pass through the surface? Second one is, what is the value of the point charge? So this is an easy one. So first point, the answer for the first question will be the same. Phi remains the same. Even though the distance or the radius is doubled, that will not come into picture. So flux is the same for the first answer. Sorry, first question. Okay. So even though the radius is doubled, flux phi remains the same. Now moving on to the second one, what are you asked to calculate? Point charge Q. Okay, point charge Q. So electric field E is equal to, Q is equal to flux phi formula, correct? Flux phi is equal to Q by epsilon naught. So Q is equal to phi into epsilon naught. What is phi? Minus 1 into 10 to minus 1 into 10 to the power 3, and substitute the value of epsilon naught. Minus is very important here because you are finding out the value of Q and you have the direction of electric field, correct? From there you have the flux also. So phi is minus 1 into 10 to the power 3 into epsilon naught will be now 4 pi into 9 into 10 to the power 9. So this is what the calculation is, and the answer comes out to be minus 8.84 into 10 to the power minus 9 coulomb, or 10 to the power minus 9 is nothing but nano. So 8.84 nano coulomb. So this is the answer for the second part under the question 1.20. So first part phi is the same value, second part you just have to use the flux concept, Gauss law. So phi is equal to Q by epsilon naught, substitute the values which are given and then get the answer. And if you write this is also fine, if you write up to here, but you can simplify the unit further as 10 to the power minus 9, writing as nano. Okay. Next is 1.21. Sorry. 1.21. The question goes like this. A conducting sphere of radius 10 centimeter has an unknown charge. If the electric field 20 centimeter from the center of the sphere is 1.5 into 10 to the power 3. So here see that radius is not important, but the distance where the electric field is counted is important. So it is, and it is radially inwards, okay? Radially inwards, remember, plus charge and minus charge, positive and negative charges. If it is minus, if the charge is minus, electric field is pointing inwards. This I have explained. If the charge is plus, electric field is pointing outwards. Okay. So in the same way here, electric field lines are pointing inwards, and what is given? Unknown charge, distance is 20 centimeter, R is 20 centimeter, and electric field is 1.5 into 10 to the power 3 Newton per coulomb. This is electric field. What you have to calculate? Net charge Q. So it is direct one. Use the electric field equation. F by Q, the initial definition, the basic definition of electric field. So you have E is equal to 1 by 4 pi epsilon naught Q by R square. For force, what will you write? Q1, Q2. For electric field, just 1 Q. So substitute the value and find out the answer for Q. So Q will be equal to E into 4 pi epsilon naught into R square. So E is 1.5 into 10 to the power 3, 4 pi epsilon naught. Either you can substitute the value for epsilon naught, or you can write it as 1 by 9 into 10 to the power 9. Correct? 1 by 4 pi epsilon naught is 9 into 10 to the power 9. So 4 pi epsilon naught will be 1 by 9 into 10 to the power 9 into r is how much? 20 centimeter. So 20 into 10 to the power minus 2 whole square, or you can directly write it as 0.2 whole square. Okay. Again, I think this comes in nanocoulomb. Answer comes out in nanocoulomb. It is minus, please include minus here. No, at the end you can include, no problem. So minus 6.67 nanocoulomb. Answer is minus, so E will be equal to minus 6.67 nanocoulomb. Why I have written minus here? Because it is given electric field is radially inwards. So when it is inwards, Q, the value of Q should be negative. This is very, very important. Negative charge is very much important, so that you write the sign at the end. Okay. Next one, 1.22. I hope this is clear. On to 1.22. Uniformly charged conducting sphere of 2.4 diameter has a surface charge density. The concept of surface charge density, that is 80 microcoulomb per meter square. We have studied 3 charge densities: linear charge density, surface charge density, and volume. Okay, so 80 microcoulomb, this is surface charge density. When surface comes, you have Q by area concept. First, find the charge on the sphere. Second one, total electric flux leaving the surface of the sphere. Again, the simple one, radius is 2.4, diameter. Diameter is 2.4 meter, and the surface charge density, sigma, is 80 microcoulomb per meter square. 80 microcoulomb per meter square. Sigma is equal to Q by A. Sphere is given here. A should be what? Q by 4 pi r square. Area of the sphere. What is R? Radius. You are given with the diameter. So find out the radius. So R will be equal to how much? 1.2 meter. Substitute that, you get the value of Q. Q will be equal to sigma 4 pi r square. Sigma is how much? 80 micro. So 10 raised to minus 6. 4 pi into 1.2 meter. 1.2 whole square. So the answer comes out to be 1.45 into 10 raised to minus 3. What should be the unit? Coulomb. Minus 3 is nothing but millicoulomb. Sorry, milli. So millicoulomb. That also you can write, or you can write up to here. So this is first part. Second part, flux you have to calculate. So this is the first part. What will be the second part? You have to calculate the flux. Again it is simple. Phi is equal to Q by epsilon naught. What is Q? This value of Q you have to substitute. So that means this calculation has to be proper, otherwise both will be wrong. 1.45 into 10 raised to minus 3 divided by epsilon naught. So for epsilon naught, either you can substitute 8.85 into 10 raised to minus 12, or 1 by epsilon naught you can write it as 4 pi into 9 into 10 to the power 9, as how I have explained in the previous one. Again I will not write. So it is the same thing. Okay. So substitute the values and get the answer. So it is 1.6 into 10 raised to 8 Newton meter square per coulomb. Newton meter square per coulomb. Next one, 1.23. So see that you solve the numericals daily, practice it daily, and be thorough with all the formulae. This is based on linear charge density now. An infinite line charge produces field 9 into 10 to the power 4 at a distance of 2 centimeter. So this is 9 into 10 to the power 4 electric field at a distance of 2 centimeter. Calculate the linear charge density. Calculate the linear charge density. This comes under applications of Gauss law, where an infinite long conductor is taken and we have used the different concepts. We have divided into small pieces and then found out the electric field. Okay, electric field due to an infinitely long conductor. So that same concept. So E will be equal to lambda by 2 pi epsilon naught r. I hope all of you will remember this equation. We have done the derivation also. What are you asked to find out now? Lambda. Direct. What is lambda? Linear charge density. So it is E into 2 pi epsilon naught into r. What is E? 9 into 10 to the power 4 into 2 pi into 8.85 into 10 raised to minus 12 into 2 centimeter, 2 into 10 raised to minus 2. This direct calculation, so 0.1 microcoulomb per meter. The simplification, micro, I think you might get in terms of 0.01 into 10 to the power minus 5. So when minus sign goes this right side, it is again increasing. So minus 6 is nothing but micro. Okay. Why it is per meter? Because linear charge density per length. Okay. So it is 0.1 microcoulomb per meter. Be careful with the substitution and then calculation. 10 to the powers are important. The last one, 1.24. Two large thin metal plates are parallel and close to each other. On their inner faces, the plates have surface charge densities of opposite signs and magnitude 1.7 into 10 to the power minus 22. Surface charge density 1.7 into 10 to the power minus 22 coulomb per meter square. What is E? The first one, in the outer region of the first plate. Second one, in the inner region, outer region of the second plate. Third one, between the plates. So on the left side, if you have two plates here, you are considered to first find out one plate, second plate, and then between. So on the left side, the first answer will be 0 because it is equal and opposite. Two plates. So first will be 0. Second case. What is the second case? What is the question they are given? On the right side, the fields of the two plates are equal and opposite. It is the same thing. Left side if you consider or right side if you consider. One or the other. So it is equal and opposite. So for the second one also it is 0. Now the thing is you have to calculate between the plates. That means you have to average that between the plates. So what is E? This also we have called sigma by 2 epsilon naught. This is the main equation that we have derived. E is equal to between the plates, thin metal sheets that we have considered. So it is sigma by 2 epsilon naught. So you have two plates here. Again you have to consider the other one. Take the average sigma by 2 epsilon naught. So E will be equal to sigma by epsilon naught. What is sigma? 1.7 into 10 raised to minus 22 and epsilon naught value. So then find out the value of electric field. It comes out around 19.2 into 10 to the power minus 10 Newton per Coulomb. Newton per Coulomb. Okay, so this is the answer for 1.24. So I hope all the exercise questions are clear to you. So please solve all the questions, and all the example numericals are also very important. Practice it daily. Daily you have to solve the numericals. Right? Yes. So see you in the next class. Thank you for watching. Thank you.